everyone, in this video we are going to focus mainly on the surface areas of solids. First, we will explore the properties of surface areas, and second, we will discover the formulas for the surface areas of the solids. These will help you to solve problems involving the surface areas. By definition, the surface area of a three-dimensional figure is the total area of the planar regions which comprise the surface of the figure. These planar regions can have polygonal shapes. It's like saying that if you have a solid, you would have to cut it, lay it flat as a two-dimensional figure, and find the total area of all the planar regions comprising the two-dimensional figure. That total area is the total surface area of the solid. Let's have the surface area of prisms first. Before we proceed, we need to understand the difference between the bases and lateral faces of a prism. So you see that every prism has two congruent parallel faces, and those are its bases. Meanwhile, the lateral faces are the other faces of the prism other than the bases. You need to understand this because basically you know that the total surface area of the prism is equal to the sum of the areas of the bases and the lateral faces. Let us focus on common prisms such as the rectangular prism. To compute the total surface area of a rectangular prism, it would be easier to visualize it using its nets. Nets are the polygons that you have when you quote-unquote cut open the solid. So we can compute the total surface area of the rectangular prism if we add all the areas of the rectangles that make it. So the lateral faces are rectangles which have areas given by the formula base times height. In this notation, the base and height of the respective rectangles are denoted by the dimensions of the rectangular prism itself. So you have LW plus LW plus WH plus WH plus LH plus LH. This can be further simplified into 2LW plus 2WH plus 2LH. Or if 2 is factored out, we will have the formula 2 times the quantity LW plus WH plus LH. Let us also have the formula for triangular prisms. So we get the area of the two triangular bases, and they are given by the formula 1/2 times the base times the height. Since we have two triangles, we have to multiply that by 2. That will be simplified later on to just base times height. Also, we get the area of each of the rectangles, so that will be the product of the respective lengths and widths of each of the rectangles. If the rectangles are congruent, then we just have to get the area of one rectangle and multiply it by 3. Basically, for prisms, we get the area of the two bases and add it to the sum of all the lateral areas. We then proceed to obtaining the surface area of pyramids. We also have to understand the difference between the base and the lateral faces of a pyramid. The base is the polygonal face that does not contain the vertex, whereas the lateral faces of the pyramid are the faces of the pyramid that share a common vertex. For pyramids, the principle is the same. We just have to add the areas of the lateral faces and the area of the base to get the total surface area. If the pyramid is regular, the lateral area is equal to 1/2 times the perimeter times the slant height plus the area of the base. We also want to learn the surface area of cylinders. The surface area of a right circular cylinder follows the same principles of adding the lateral area and the area of the bases. First, let's look at the lateral area. If we cut it open, we see that the lateral face of a right circular cylinder is actually a rectangle. The area of any rectangle is equal to the base times the height. The base is actually the circumference of the cylinder given by the formula 2 pi r, and the height is the height of the cylinder itself. So the area of the lateral face of a right circular cylinder is equal to 2 pi r h. Next, we have to find the area of the bases. Since the bases are two congruent and parallel circles, the area is equal to pi r squared times 2. Thus, the total surface area is equal to the lateral area 2 pi r h plus the area of the bases 2 pi r squared. Let's also find the formula for the surface area of cones. The surface area of a right circular cone also follows the same formula as that of any solid. We have to add the lateral area, which is a sector in this case, and the area of the base, which is a circle. The area of the sector is equal to 1/2 times the circumference 2 pi r times the radius of the sector, which is also the slant height L of the cone. Meanwhile, the area of the circular base is equal to pi r squared. When simplified, 1/2 times 2 pi r L is equal to pi r L, and of course we have to add the area of the circle, which is pi r squared. So the total surface area of the cone is equal to pi r L plus pi r squared. Let's now go to the last formula for this video, which is the surface area of spheres. The surface area of a sphere is equal to the sum of the areas of the 4 circles that fill its surface. So that is pi r squared plus pi r squared plus pi r squared plus pi r squared. Or when simplified, that is 4 pi r squared. To see 2 proofs on why 4 circles are needed to completely fill the surface of the sphere, please scan the QR code on the screen. This will take you to a video of the proofs. So that's it, the formulas for the surface areas of solids. We can now use that to solve the problems in your learning guides.